In this lesson you will learn how to display and use AlphaEarth satellite embeddings with Google Earth Engine. AlphaEarth embeddings are high-dimensional vector representations of locations on Earth, generated by a sophisticated AI model. These vectors encode the rich, multifaceted context of a geographic point, allowing to understand and reason about places in a way that goes far beyond simple coordinates. In this notebook we will use Google Earth Engine. Google Earth Engine combines a multi-petabyte catalog of satellite imagery and geospatial datasets with planetary scale analysis capabilities. What information might an Earth embedding capture? Examples are physical geography, human geography, infrastructure, climate and weather, economic activity, and ecological context. So, a point in a forest and a point in a desert would have very different embedding vectors, even if their latitudes are similar. In this lesson we will use the embeddings to do land change detection and clustering of similar pixels through unsupervised learning. Let's start our notebook by importing all the needed libraries. We need now to authenticate and initialize the Google Earth Engine project. You can force the connection. In this case it will ask for the account to use and you should follow the instructions. If you want to have more details on how to create a Google Earth Engine project, you can follow up from the Google official code reported in the link in the comment. Visualizing the AlphaEarth embeddings is very easy. You can use a specific GUI that was created for the project with LeafMap. Once the visualization is available you should select the embeddings you want to apply. The loading can be slow since we're loading a huge amount of data. All the calculation is being done on Google server side. You can use the GUI to visualize specific area of the Earth. For visualization we selected only 3 bands in order to render the image in false RGB colors. Areas with similar features or patterns will have same colors. Let's now display a simple AOI. In this case, notice you have to select the dataset corresponding to AlphaEarth embeddings. It is called Satellite Embedding V1. Once we have selected the area and the dataset we can display the image. Several applications are available thanks to these embeddings. In this notebook I'll show how to use embeddings for change detection, unsupervised learning for potentially land use and land cover detection. Let's start with change detection. Change detection is the task to detect differences between pixels of the same areas at 2 different dates. In this case we will check the change occurred for a specific AOI for years 2022 and 2023. In order to select embeddings for 1 year, year N, it is sufficient to select a period starting from January 1st of year N to January 1st of year N plus 1. We can also filter by selecting where our window should be selected. All the calculations are done on server side as well as layers values. In the next cell of code I've just pulled the data locally for inspection of the sizes. We can now visualize both embeddings with some specific color scale. For visualization we can select 3 bands of all the 64 available. Each pixel in these Earth Engine images represents a vector of features, 64 high-dimensional embeddings that encode semantic information about land cover, crop type, or other spatial patterns learned by a model like AlphaEarth. So in practice in order to detect change between one year to the other we can do the dot product between vectors. The dot product image highlights areas where the land cover changed semantically between the 2 dates. It's a simple change detection proxy in embedding space, not raw reflectance difference, but feature-level difference. Areas in white are areas with low similarity, i.e. an area with a large change 1 year with respect to the other. On the opposite, black areas are areas with high similarity. As second application we're going to see how to do unsupervised learning with k-means clustering. The purpose is to group similar pixels, i.e. pixels where embeddings are similar. Once similar pixels are identified it could be possible to create a LULC map by manually labeling each crop type detected. Let's now display the embeddings on of the area of interest. Thanks to Google Earth Engine functions we can do k-means clustering and display existing clusters. In this case we can select 5 clusters. We have firstly to train the algorithm on a few samples and then do inference on the whole image. We can see that the algorithm has clustered similar areas with same colors. These areas correspond, for instance, to cities, crops, forests, water bodies. We could, for instance, overlap these clusters with an existing map to understand the meaning of each cluster. We have now arrived at the end of this video. In this lesson we have learned how to manipulate AlphaEarth embeddings thanks to Google Earth Engine. If you have liked the video, please do not forget to subscribe to my YouTube channel.